All right, folks. Today we're going to talk about one of the hardest things that exists for me. This, I am going to straight up tell you, is one of the trickiest things you will ever do. That's right, folks. We're going to learn how to count. So, what is counting? Counting is simply trying to figure out how many of something there are. If I ask you to count the number of fingers you have on your hands, many of you will say 10. Some of you will argue that there are only 8 fingers because the thumbs don't count for some crazy reason, because you're just strange. And I don't believe I saw any of you missing a finger, but if any of you were, you'd tell me that there were that many fingers. It's very simple. You just went if I asked you to count, you'd take hands out and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or whatever number you would aim for. Let's say we had a situation. Say you went to a pizza place. Honestly, it kind of looks like a Little Caesars menu to me, except you wouldn't get a choice of small and medium. Clearly, you'd just take the large. Let's say you went to a pizza place and you said that you wanted to know how many pizzas they could make. Now, at first sight, many people would argue that they have 5 types of pizzas. And we're only going to do single-topping pizzas here. We're not going to get into the multi-topping pizzas quite yet. We'll get there in a minute. So, we got this pizza place, and I ask how many pizzas they can make. Some people look at that and they'll say there's 5. There are cheese, pepperoni, ham, sausage, and mushroom pizzas. And that sounds like a great idea, except, of course, if I order a small ham pizza, that should cost something different than a medium ham pizza or a large ham pizza. Or if I get a small pepperoni pizza, I should get the same exact price as if I ordered a small sausage pizza, because they're both one-topping pizzas, and I shouldn't have to pay extra for that. So we realize that there's more than just one particular, there's more than 5 pizzas here. So the question becomes, how many are there? And there's a couple options we have here. One of the options we have is we could write out every stinking combination. See, we could have a small cheese and a small pepperoni and a small ham and a small sausage and a small mushroom. We could have, we'll do this one in purple. We could have a medium cheese. We could have a medium pepperoni, a medium ham, a medium sausage, and a medium mushroom. Or we could have, of course, we could have larges. We could have a large cheese, a large pepperoni, a large ham, a large sausage, and a large mushroom. And if we rule out all of those combinations, we would say that there are 15 choices. Hey, cool, 15. That's a whole lot more than we actually expected from this small pizza place. Another option we could do, if we thought that this was maybe a little too complicated, is we could draw lines. We could say, well, the small has 1, 2, 3, 4, 5, and the medium is 1, 2, 3, 4, 5, and the large has 1, 2, 3, 4, 5, and we could try to count all those terribly, terribly confusing lines and find out that there are 15 lines. Or we can utilize what is called the multiplication principle. And the multiplication principle simply says this. The multiplication principle says how many things are in one set, how many things are in the other set. And if I'm selecting just one thing from multiple sets, all I have to do is multiply how many things are there. You see, in this case, I have 3 sizes, and I have 5 toppings, and last time I checked, 3 times 5 is 15. And oh my goodness, this is the most amazing, and Mr. Ackerman, you said that this is hard. Why is this hard? This isn't bad. And I could even make this, let's take this problem to another extreme, okay? Now I'm going to really mess with you. Now not only do I have a size, let's go personal, small, medium, large, and extra large pizzas. And let's go, we've got our crust types this time. And let's go that we've got, what do we got? We have thin, we have regular, and we have pan pizzas. And let's say we've got toppings, and oh my goodness. let's face it, man. Pizza places, they got all sorts. You've got cheese, you've got ham, you've got pepperoni, you've got sausage and mushrooms, you've got onions and green peppers, you've got you got pineapple, and I already know that a few of you are going, pineapple, Mr. Ekman, that doesn't belong on a pizza. Hey, don't bash on the pineapple. We could, we can throw some anchovies on there. Oh my goodness, there's green olives and there's black olives. We'll just stop there. Okay, I worked at a pizza place, so there's a whole bunch of toppings that I'm still not including. And I asked how many pizzas this place actually could produce. How many different one-topping pizzas could they have? Well, I certainly don't want to have to sit there and come up with the fact that this is going to come here, and then I'm going to go here to here and do all of these, and then I'm going to go here to here and do all of those, and then I'm going to have to do that again for the smalls and the mediums and the larges and the extra. Oh my goodness, it's going to be crazy, and I certainly don't want to have to write out all of these. So what do we look at? We say, well, okay, this particular place has how many sizes? 1, 2, 3, 4, 5. 5 sizes. How many crusts? 3 crusts. How many toppings? We got 1, 2, 3, 4, 7, 8, 9, 10, 11. We got 11 toppings. Cool. So what does that become? That is a number I don't want to think about right now. 15 times 11. This particular pizza place has exactly 165 one-topping pizzas. Cool. What did we just do? We just figured out, we just counted to 165 a whole lot faster than having to count by ones. That is the counting principle. That is the multiplication principle. Now, can make things a little bit harder. Let's say we have a classroom of 20 students. Let's say it's a club. And we need a pres and a VP for this particular club. See, this is where counting becomes a bit of a pain. See, if we really think this through, and if we came up with 20 individual students, maybe we call them A, B, C, D, E, F, G, maybe we call them 1, 2, 3, 4, 5, although I don't suggest using numbers to organize your people. But we can go A, B, C, D, F, G until we hit 20, and we can kind of go through that way, and we can try to come up with that combination. One of the things we have to be careful of is we have to realize, some people will go, well, okay, let's think logically about this. We have 20 students for a president, right? We're going to vote for a president first. So for the president, we're going to have 20 choices. Well, but what about for the vice president? How many choices are we going to have? And when we start thinking about that, hopefully we realize that voting your president as a vice president is a bad idea. The whole point is to have 2 different individuals. See, this is where counting is going to start getting tricky. This was an easy example still. See, in this problem, we don't have 20 choices. We have 19 choices. Since one person is the president. Meaning that if everybody were equally likely to get this particular position, then we would have, oh crud, so then you think to yourself, hey, that sounds pretty cool. And this is one of the scenarios that they raise inside the math textbook, because they bring up this. But then, I could make this even more interesting. See, because we've got this situation that's in front of us. But what about this one? Hold on, I got to think about this now. There are 7 Harry Potter movies, I believe. If I get the number of movies wrong, not books, movies. I'm going to go with movies. Yes, I'm going to just go with it. Let's say you have I've got 7 Harry Potter movies sitting at home. Just chilling. It's the weekend. Studied my AcDec stuff. Not doing what I'm supposed to be doing, which is keep studying my AcDec stuff. I got my homework done. No one wants to hang out. Everybody else got grounded, which means it feels like you've been grounded. There's no football games to go to. You know, your car broke down, something happened. Couldn't get to where you needed to go. Got your 7 Harry Potter movies, and you decide that you're going to want to watch. You got time. You want to watch 2 movies. All right? And the question becomes, how many combinations? Let me make sure that I have this this wording correct, because I want to make sure that this wording is really, really, really good. Because I think I used a word in here that I didn't really want to use. How many ways can I pick 2 movies to watch? There we go. I like that. How many ways See, so this becomes an interesting thing. And I'm actually going to list all the different combinations here. So I'm just going to do them in Roman numerals. I could watch 1 and 2. I could watch 1 and 3. Watch 1 and 4. 1 and 5. 1 and 6. 1 and 7. All right, cool. Go me. I could watch, and then technically there's like a 1 and 1 spot up here. Now, I'm not going to watch 1 and 1 because I don't want to do that. So that spot is gone. I'm going to leave that spot empty here. I could watch 2 and 1. Can't watch 2 and 2. That's not going to work. I can watch 2 and 3. I can watch 2, 2, 2, 2, 4, 5, 6, and 7. Cool. What else can I watch? I can watch 3 and 3. That's 3 and 1, 3 and 2. 3 and 3 is going to be useless. 1, 2, 3. I can watch 3 and 4 and 5 and 6 and 7. I can watch 4 and 1. I could watch 5 and 1. I could watch 6 and 1. I could watch 7 and 1. And you're starting to get an idea of what the heck is going on here. I've got 4, 4. That one's going to be blank. 4, 4, 4, 5, 5. Can't watch that one. 5 and 5. And I'm going to real quick take some time here. All right, and you can see how this all pans out after it all comes back up. Now, here's the reason why this is kind of strange. So I asked, how many ways can I pick 2 movies? So, using the previous thought process from the problem we looked at before, we could argue that, well, we can watch one of 7 movies first. We would have 7 choices. And then we would get 6 choices, and we could say there are 42. And if you were to go through here and count up all of these items, You could say that there are 42 ways we can pick 2 movies. But let me ask you, if I'm picking 2 movies to watch, is ways that I can pick 2 movies, do I mean just, does episode 1, 2 really differ from episode 2, 1? If you're a person who says yes, then 42 is clearly the correct answer. However, if we think that 1, 2, and 2, 1, hey, I'm still watching 2 movies, it's just that I'm watching them in a different order, well, now we've got a little bit of an interesting thing, because you see 1, 2 is the same as 2, 1. And 1, 3 is the same as 3, 1. And we could say 1, 4 is the same as 1, 4. And 5, 1. And we can start saying that everything above that line right here, every single one of those is wrong. And if we count these up, well, I just crossed off half of the numbers. And in this case, we would say that this is 7 times 6, and we could divide that by 2, and we could say that there are 21 different ways. See, the significance of this argument is what's more important. What is the question asking? Does the order matter or not? That's what we're going to come up with in the next video, is building up on the concept of more complicated problems where order will count and order will not. So that is just a start to counting, and I look forward to putting up the next video.